Hello, Chemistry 10HH student. This is Mrs. Altman. We are on video number 39, Gases, Part 5. Here are our objectives for today's video. Pause here. So we've talked about the ideal gas law, and now we're going to talk about kinetic molecular theory, which really explains why the ideal gas law works. I'm going to reference it as KMT. So it's describing the properties of an ideal gas and why the ideal gas law works the way it works. The next video, we're going to talk about things that aren't ideal, so we need to really understand why things are ideal. This video is really just notes. There aren't actually any examples or calculations with it. It's just important that we get this information. Pause here. The first postulate is that gas particles are so small that the volume is negligible. So what that means is if I have a 1 liter container, if I put a gas in there, there is still 1 liter of available space. As opposed to a liquid, if I take a 1 liter container and I fill it halfway with liquid, I only have half of that space available now for that's empty space effectively. So that's something that makes a gas different from a solid or a liquid. Pause here. The second postulate is that gas particles are in constant motion and high speed motion at that, and that the collisions that happen as a result of this motion create pressure. So as something cools down and becomes a liquid, its motion slows down and its pressure will also decrease as a result of this. So think of it as an ideal gas is like the opposite of a liquid. It's typically going to be more ideal at higher temperatures where it's moving faster. Pause here. The third postulate, and the one that is really the most problematic when we start talking about things that are not ideal, is that there's no attractive or repulsive forces between gas particles, meaning no intermolecular forces. And you'll see that this is just not true for a lot of gases, but for an ideal gas, that will be true. Things that are ideal tend to be like noble gases because they don't really have very polar bonds since they are atoms, not molecules. If you did have attractive forces between gas particles, that would make the pressure lower than what you would project using PV equals nRT. Pause here. All right, then the fourth postulate is just the average kinetic energy is directly related to Kelvin temperature. So what that means is that the higher the Kelvin temperature, the higher the average speed. If you didn't already know the definition of kinetic energy, I'll give one right now. So kinetic energy, mathematically, you'll see this when you take physics, whether next year or 2 years from now, is just 1/2 mv squared, where m is mass, which is measured typically in kilograms, and v is velocity, which is typically measured in meters per second. You're not really going to need like calculations with this, but what this also tells us is if I have 2 gases at the same temperature, the one that is lighter is moving faster. Pause here. Yeah, I guess I didn't need to do that. I forgot that this was here. You don't need to write it twice. Pause here. This is the last slide. So this equation here, we will practice with in class. It's something I'm more giving you for conceptual purposes than anything else. So diffusion, you probably have learned about this in biology, just the rate at which something disperses. In chemistry, we're going to apply it to a gas. Whereas effusion is the rate at which a gas moves through a small hole. For example, if you were to take an aerosol spray and stab it with a knife, that's an example of effusion. So then Graham, which was just a scientist a while ago, he has a law of effusion, which is the rate of one gas over the rate of the other gas is equal to MWs for molar mass. That's just a sort of old-fashioned way, abbreviation, MW for molar weight. So it is equal to the square root of the gas 2 over the square root of gas 1. What this really means is that heavier gases are moving slower. That's the important part to understand. Okay, that's all for tonight. Thank you so much for watching and have a great night.